Given the function q of x equals 1/2 parenthesis x minus 1 cubed plus 4, find the sketch of this function using transformations and locate the x-intercepts and the y-intercept. So let's outline how we're going to do this problem. First step, we're going to identify the basic function that's related to this q of x. Step 2, we're going to identify the variations that will be done to the basic function to get this new graph, this new function. And then step 3, we'll do a sketch of the function using the basic graph and the variations. So back to step 1. What is our basic function? Look at the q of x. What does it look like? It looks like the very simple basic function f of x equals x to the third power. And now you need to remember what that picture looks like. We'll graph it on the y and x axis. It's like a snake slithering through the origin 0, 0. It has points at 1, 1, 0, 0, and negative 1, negative 1. And if you don't believe that, choose the x values, negative 1, x value 0, x value 1, and run it through f of x to get the y partner. Okay, step 2, we're going to find the variations of that occur to acquire our new function q of x. So write the given function y equals 1/2 parenthesis x minus 1 to the third power plus 4. Now, the first thing we notice is that there's a 1/2 multiplying in the front. We're going to call this variation A. That results in a vertical compression. And what that does, it takes the ordered pairs x, y in the basic graph of the basic function f of x, and it changes it by multiplying the y coordinate by 1/2, so it becomes x comma 1/2 times y. The second variation we see is occurring at the one that's being subtracted from the x. When we do anything to the x, it's always the opposite of what you assume is going to happen. Instead of shifting to the left 1 unit, we're going to shift to the right. So this is variation B, and that minus 1 indicates we will shift our graph to the right 1 unit. That means the ordered pairs in the basic graph, xy, will change by adding 1 to the x coordinate. That will cause a shift to the right, so it becomes x plus 1, comma, y. Now our last variation, variation C, occurs at the end where we're adding 4. What happens when you add 4 outside of the function evaluation? You're going to shift up 4 units. And how that's translated is that the ordered pairs x, y in the basic function f of x are now going to be changed by adding a 4 to the y coordinate, so they become x comma y plus 4. Okay, now we're ready to do the sketch table. First, we're going to list the ordered pairs in the basic graph that we drew at the top. It has the ordered pairs negative 1, 0, 0, and 1, 1. Now we're going to do a variation on each of those points in the basic graph just using step A. In other words, we're going to go through each of those ordered pairs and just multiply the second coordinate, the y coordinate, by 1/2. So for step A, our ordered pairs will change to negative 1, negative 1/2, 0, 0, because if you multiply the y coordinate by 1/2, it's still 0. And finally, the 1, 1 becomes 1, 1/2. Now for step B, we're going to go through these ordered pairs that we just acquired for step A, and we're going to make a modification to the x coordinate. We're going to add 1 as described in step B. Okay, so our first ordered pair, negative 1, negative 1/2, it's got to change by adding 1 to the x coordinate, so it becomes the ordered pair 0, comma, negative 1/2. Now when we do the same change to the 0, 0 ordered pair in step A, in other words, when we add 1 to the x coordinate, it becomes the ordered pair 1, 0. And then if we do the same change, add 1 to the x coordinate to the ordered pair 1, 1/2, we get the ordered pair 2, 1/2. Finally, we go to step 3. Step 3 told us that we have to change the ordered pair by adding 4 to the y coordinate. That's going to change the ordered pair in step B from 0, negative 1/2, to 0, comma, 3.5. That's what happens when you add 4 to the y coordinate. Now let's change the ordered pair 1, 0 by adding 4 to the y coordinate. We get 1, 4. And finally, change the ordered pair 2, comma, 1/2 by adding 4 to the y coordinate, and we'll get the ordered pair 2, comma, 4 and 1/2. So I'm putting a little star and a check mark here because it's just step C, all the ordered pairs in the last row that are going to appear in the final graph of our Q of X function. So let's get ready to graph this. Let's graph each of these ordered pairs. Let's see, we've got the 0, 3.5 located on the y-axis. Then we have the ordered pair 1, 4 drawn in, and now the ordered pair 2 for the x-coordinate up to 4.5 for the y-coordinate. Okay, right there, 2, 4.5. All right, so now here's a dotted line, and we're going to do the snake coming down. Well, here I do the dotted lines to show you how the origin has shifted. It's shifted up 4 units. It's shifted to the right 1 unit. So what used to be the origin is now located at the ordered pair 1, 4. And it helps us to draw the graph. It's going to snake through the new origin, which is actually the ordered pair 1, 4, and come back out the other side and pass through these points. Okay, so they also asked us to find the x and y intercept. To find the x-intercept, we just take the Q of x function, we let y equal 0. So 0 is equal to 1/2 parenthesis x minus 1 cubed plus 4. Let's solve this for x. Okay, we multiply both sides by the 2, the LCD, to get rid of the fraction. Then we move things over to the other side, take the cube root of both sides in order to get rid of this third power. The cube root of -8 is -2, so x minus 1 equals -2, so x is equal to -1. So we let y equal 0 at the beginning. Our x-intercept is the ordered pair -1, 0. And indeed, we have actually graphed that point on the graph. -1 on the x-axis, 0 on the y. The y-intercept, it's actually already located in our table for step 3. It's the ordered pair 0 for the x position and 3.5 for the y position. And we've already graphed that also. So there's the points. And that's a picture of our new function Q of x.